So now that we know about solids, liquids, and gases, another way to classify matter is based on the composition of that matter. And we're going to go through this diagram from the textbook. Notice at the top of the diagram we start with matter. So basically anything that occupies space and has mass would fall into here. And then we're going to split that into either pure substances or mixtures. And pure substances will be further broken down into either elements or compounds, and mixtures are either homogeneous or heterogeneous. So first, let's look at what these terms mean. A pure substance is a sample that's made up of one type of element and the elements are found on the periodic table, or one type of compound. And a compound is a combination that's made of two or more elements. So it's easier to see with some examples. On the periodic table, you have the list of all of the elements. So you'll see something like capital A, lowercase g, which is the abbreviation for silver. So if you had a sample that was pure silver, that would be a pure substance, and you could also call it just an element. If you had a compound, you're going to have two or more elements chemically connected together. So for example, H2O, water. Water is not found on the periodic table. It's a compound that's made of two hydrogen atoms chemically connected to one oxygen atom. A mixture is a sample that contains more than one pure substance. And if that mixture is uniform, so in other words, if you get the same properties everywhere where you take a sample out, top, middle, bottom, then that is a homogeneous mixture. So for example, if you have a cup of coffee, coffee is not an element, it's not just one compound, it is a mixture of many compounds together, so coffee would be a mixture. Black coffee is uniform, doesn't matter if you look at the top, the middle, or the bottom, that's a homogeneous mixture. A heterogeneous mixture is when it is not uniform. So instead of just black coffee, if you had iced coffee, now you have a mixture of coffee and ice, and that sample is no longer uniform. That would be a heterogeneous mixture. So looking back at this diagram, here's some more examples. So on the left, on the pure substances, an element, what they're trying to show here are two different pictures, macroscopic and microscopic. This is showing iron atoms together, and this is in the shape of a solid. So iron is capital F, lowercase e, it's in a solid. This we know is an element because it cannot be broken down into any other elements. In other words, that's as simple as it can be. So what they're trying to show is a macroscopic picture of a sample, a nail that's pure, iron. Next to that you have a compound. Compounds are easy to tell from the microscopic picture because you have two or more atoms, two different color atoms chemically connected. This is a sample of sugar, which is a compound made up of carbon, hydrogen, and oxygen. On the mixture side, the homogeneous mixture, they're showing a cup of tea that has a little bit of sugar dissolved in it. So microscopically, you can see that we don't have just one pure substance. We have more than one mixed together. We have water, we have the compounds in the tea, and we also have the sugar. But it is uniform everywhere, so it's a homogeneous mixture. A homogeneous mixture is also called a solution. And then the last picture is a heterogeneous mixture. It's not uniform. We have one layer on the top, which is oil, and we have a layer on the bottom, which is water. So if you took a sample at the top, you would get almost all oil. If you took a sample on the bottom, it would be almost all oil. And if you took a sample in the middle, you'd have a mixture of both. So this is a mixture of oil and water, which is heterogeneous.